Well, our next story is about showers, but we're not talking about the weather, rather a trio of meteor showers. And to tell us more, ANU astrophysicist and cosmologist Brad Tucker. Tell us about these three meteor showers happening this weekend.
It's kind of three showers kind of all coming together with one that's one of the better ones, what we call the Delta Aquariids. So meteor showers. Meteor showers are bits of rock and ice that fall off things like comets. So for instance, the Delta Aquariids are bits of Halley's Comet. So little bits of Halley's Comet have come off as it's gone around the solar system. And then as the Earth passes through it, it burns up as shooting stars. Now, the shooting stars, it's kind of this misnomer. They're not stars at all, but they are just flaming chunks of rock. But they're tiny chunks of rock. And so that means that if you go outside at the right time for one of these meteor showers, you can see, in some cases, maybe a dozen or 2 dozen per hour. So you can actually see, quite a few shooting stars in a chunk of time.
It's quite amazing, isn't it? And you must be amazed in your job. I suppose it's a constant amazement every day that you go to work.
So, the meteor shower is kind of a nice thing as part of that amazement, I guess, because so many things we could do. They're so far away or they're so small, and you can't see them with your own eyes. But with a meteor shower, you can. You don't need special equipment. You don't need a telescope. You just have to go outside and look. And I think that's kind of one of the great things here is that you can see the beauty of these events, these bright streaks going across the sky in your screen as we're talking. And that's just it. You see them. And then you can realize, there's this little bit of comet, and it's Halley's Comet that went around the solar system and left this trail of debris. So it's a really great kind of juxtaposition between seeing the complex yet doing it with your own eyes.
It is so vast, isn't it? Words often aren't good enough to explain what we have up there in space.
It is. It's such a big place. I mean, the fact that firstly these meteors are only grains of sand. These things are so tiny. We see them as these bright streaks, but they're little specks of dust, maybe tiny rocks, and they're burning up that bright. But then all of the stuff that you add up, all of the meteors, and then all of the stars and galaxies and planets out there, it becomes an awfully big place. And so it's nice to be able to interact with it sometimes, on a personal, so to speak, scale. So it's always nice when you think about the vastness of space. It can almost seem daunting when you think, hey, there's 100 billion stars or 300 billion stars in our Milky Way, and they all have planets around them, and then there's trillions of galaxies, all with stars, all with planets. You can almost feel so small and insignificant, but then at the same time, you can go outside and appreciate the beauty of it.
Oh, absolutely. Absolutely. Now, what about this Chinese rocket?
So there's, it's a different kind of thing to look for falling from the sky in a really weird way. So last weekend, China launched the Long March 5B. Now, this is the heaviest rocket that China has, and it took up the second main part of their space station. So China's building their own space station, the Tiangong space station. Now, the problem is when that rocket goes up, there's no fuel for it to come back down in what we call a controlled orbit. So usually you try and steer these bits into the ocean so that they break apart and then they land safely in the ocean. This is not the case. So we don't know exactly when or where this bit of debris is going to fall. So the current estimates are putting at Sunday morning, so tomorrow morning, kind of around 4 a.m. That's kind of the predicted time that will come down right now, but that's kind of plus or minus 5 hours. So it could be any time from kind of midnight to midday on Sunday. And the problem is if you don't know exactly when, you don't know exactly where. This thing is traveling 25,000 kilometers an hour. So if you're off by 10 minutes, that's almost 1,000 kilometers or so. So this is a huge chunk of uncertainty. So there are a number of paths that are taking it over Australia. So there's a very small chance that a bit of it does break up over Australia. It's insignificantly in terms of the worry that's going to fall on you, but it could fall in Australia. There is that chance.
Now let's talk about some of the water cooler chat in and around your discipline. Now, it's often been said to me by some people that there are more planets than there are grains of sand on beaches in all the world that we live in, or the earth that we live in. Is that true?
Yeah, you can simply add up that, so we think our Milky Way has 300 billion stars. On average, we say that an average galaxy has 100 billion stars. Now, we think there's about 2 trillion galaxies, each without 100 billion stars. So stars always becomes borderline, but as you said, planets. Now, we now know there are multiple planets around each of those stars, and multiple objects. We know of lots of planetary systems that have 4, 5, 6, sometimes even 8 planets going around it, much like our own solar system. So then you add up that there's, 5 to 10 planets around each of those stars, 100 billion stars in each of these galaxies, 2 trillion galaxies. Yeah, you can actually add it up. And based on the estimates, there are far more planets in the universe than there are grains of sand on on the Earth.
Is it true that some of the stars we look at night don't exist anymore because of the time it takes for light to travel?
So this one is unlikely, only because the stars that you can see with your own eyes are actually relatively close. So they're only anywhere between, well, the closest one's only 4 light years away. It takes light 4 years to get to us. Some are a few hundred. There's 1 or 2 that are 1,000. So it's unlikely that those have disappeared. But when we look at further with images and telescopes, it is most definitely the case that there are things that we look at, and when we finally take the image, that thing has changed or gone. But there will be cases as this happens. So, a great example is Betelgeuse. It's the big red star in the constellation Orion. Sometimes we call it the saucepan in Australia. Now, this is a red supergiant that we know is going to blow up and die. Now, because it's hundreds of light years away, that could have already happened, and then it's still going to take a few hundred years for that explosion to reach us here on Earth and for us to detect it. Or it couldn't have happened yet, and then we still have to wait another 600-700 years. So, there's a small chance that it's definitely true, but in the most cases, when we look out across the universe, we're looking at a piece of time, and this is kind of what you're doing in astrophysics, is you're looking at all of these different chunks of time and putting the picture together. We can't really just stand around and watch a human grow from a baby to a toddler to an adult and an older in an immediate chunk of time. We have to either look at lots of different people or wait a really long time. So in astrophysics, we look at lots of different objects at different times to kind of put a picture together about what these things are doing. And so that also means that you're looking at things that are no longer like they are, no longer exist.
Yeah, it's amazing. Look, do you think we're any closer to, with all the amount going on, are we any closer to finding life up there?
Yeah, look, I think that answer is going to be finally found, maybe within a decade. We're getting so close to finding it on Mars. Now, look, on Mars, it's going to be bacteria, simple cell organisms. It's not going to be Marvin the Martian or something like that waving at us. But I think we are going to find it. In fact, NASA just recently announced that they're going to start taking samples back from Mars to Earth in 2033 to analyze on Earth. So all the stuff that we find on Mars and the things that we think are likely that life, to bring it back and study back here in the lab. And everything points to that there was lots of water on Mars. The conditions are right for supporting life, so it just makes sense. But then we can extend to some of the moons of Jupiter and Saturn. We will have missions launched to as well, like Titan and Enceladus and Europa. These are moons around these planets, but they have more water than Earth. Like, some of them have 10 times the amount of water of Earth. And so if we think the possibilities of life are there, where they're so great, and now with technology, the way we've advanced in space and the cost, we can send missions to look for life as well. So, this is going to be a question that we actually do get an answer to, within, I would say, about 10 or so years. And I think that's really exciting, but it also then really changes our knowledge, our perspective, and our insight on and what that all means and what life means itself.
Yeah, I love the space. I love the whole discussion. It's fantastic, and it does make you feel insignificant, doesn't it, when you talk in these kinds of numbers?
It does, but it's great to always realize that despite everything, there's been a process from the Big Bang to today to bring us to this conversation, and in fact, I think it's an elegant picture, and that's one that's definitely worth appreciating.
Absolutely, Brad. Have a good weekend, mate. Stay warm down there in Canberra. I saw 6.5 degrees this morning.
balmy. Take care.